Correlation versus causation. Let's see. Let's say I stay at a very sunny place. I might end up eating a lot of ice creams. I might also have a lot of sun exposure leading to wrinkles. Now, if I blindly look at data, I might conclude that eating ice creams might be leading to wrinkles, which does not make any sense, right? Because there is this common cause, which is the sun, which is causing me to eat ice creams as well as causing the wrinkles, right? So, correlation is not always causation. So, eating ice creams and having wrinkles might be correlated, but it does not mean that one of them is causing the other, right? As you might have heard many times, correlation is not necessarily causation. When there is causation, there is usually correlation, right? So because if you know that sun causes you to want to eat ice creams, there will be a correlation between the temperature of a place and the ice cream sales, right? So correlation is always seen almost with causation, right? But causation does not necessarily imply correlation. Now let's see, how do we figure out whether something is correlation or causation, right? That's the more interesting question. So how do you first see if there is correlation? That's the first step, because even if you have causation, usually you'll have correlation. If there is no correlation, probably there is less likelihood of causation as well, right? So how do you measure correlation? You can just plot a scatter plot, and this is pretty simple to do in Python, right? So you take your x and y and do a scatter plot. If you see these points aligned along, let's say, a straight line with a positive slope, then you can see that they're positively correlated, which means one variable is increasing with the other. In this case, you can see that the two variables, the x and y axes, the variables on the x and y axes are negatively correlated, because when the x is increasing, the y is decreasing, and so on, right? In this case, there is a weak correlation. So as you can see, these points are a bit more scattered, indicating that the correlation is weaker. And if you don't see either positive or a negative line, if it's just like scattered, then it's no correlation, right? You would have seen this at in other places as well. So how to measure causation? Let's say there is correlation. Now we want to see, is that causation or just correlation, right? So typically the way to measure causation is through experimental design. People do A/B tests typically. That's one very common way of doing things. So for example, suppose you introduced a feature on the website, and you have the star feature that you introduced, and you want to see that whether it is leading to an increased conversion. So what do? So you typically you divide your data into multiple groups. Here two groups. One is called the treatment, the other is called the control. So in the control, you do not change anything. In the treatment, you add your new feature, right? The important thing here is everything else needs to be the same, right? And then you see if the control group has an increased conversion over a period of time, right? And how to do A/B tests is something you can actually see in more detail in other videos, right? But experimental design is a way of seeing if there is causation. So this will tell me that introducing the new feature caused more conversions, because over a period of time everything else was the same, but the only thing that changed is the new feature, and that actually caused an increase in conversions, right? Sometimes though, it's not easy to do experimental design. So you do not always have the luxury of getting a live audience to come and test your product. So sometimes you just have a data set, and from that you might actually want to figure out whether feature X is the cause of what you see in column Y, and so on, right? And there can be some smart ways of figuring out something similar to what we are seeing here without actually doing this live test, but we won't go into details of that in this video, right? But the crux of this whole slide is that you can design an experiment to measure causation, for instance A/B tests. So to conclude, we looked at correlation and causation, And we saw that when there is causation, usually there is correlation. But correlation does not necessarily imply causation. And we can actually see if there is, first we see if there is correlation. If there is correlation, we can see if there is causation using experimental design, like A/B tests. Right? Thank you.